Okay, hopefully people are patient on the live stream. All right. Hello, everybody. Come on in. Thanks for coming by. Let me switch presentations here. Okay, how many people is this their first Bitcoin and open blockchain meetup? We have a handful? Yes. Cool, 1, 2, 3, 4, first. 5, okay, cool. And so a little background, this meetup group has actually been around for now 11 years, since 2013. I'm still not the quote unquote head organizer of the meetup. It was founded in 2013 before I even knew about Bitcoin, and was the path by which I was able to meet a lot of people in the Bitcoin cryptocurrency ecosystem, and even all of the co-founders of our company here at Edge. My name is Paul Puey. I'm CEO co-founder of Edge, and I'm also one of the organizers of this Bitcoin open blockchain meetup. For any of you that need Wi-Fi, Edge Guest is available. I like big bits, password. So some logistics. Many of you might have found out about the meetup through various paths. We post in a few places, but the one place that the meetup will regularly be updating folks, what we're trying to migrate to, is Luma. It's kind of the better meetup.com. We call it a meetup. I think meetup.com kind of created the term, but in Luma it's events. So if you can somehow remember that, Luma, lu.ma, Bitcoin San Diego, or if you'd like, here's a QR code. So you're welcome to scan a QR code and sign up for the Luma group. Call it a meetup. I think meetup.com kind of created. I think I'm streaming onto my own phone. Yeah, feel free to go and join the Luma group, and it will give you notifications of any of the additional events. And we try to have events about once per month with various speakers. We've had speakers in the cryptocurrency space from around the country come on by, sometimes outside of the country, to give presentations on various projects and topics. So our organizing team, myself, I'm Paul. Chris Groshong, half of our organizing team is unfortunately out of town today. But myself, Chris Groshong, who runs a cryptocurrency startup here in San Diego. Madison, who does design on our team. Joe back there in the white shirt, definitely helping out this past year with a lot of the logistics. He's got the mic. If you guys have any questions, this is getting live streamed and recorded. So one thing we'd like to do is make sure people can hear you when you ask the questions. So pause as the mic gets around. And then Ross, who's actually not here today, he actually works for another crypto kind of fintech company out of San Diego. Well, the company's not, but he is. And then Daniel, also on our team at the support side. Right there, we've all got the little organization badges. As well, we're looking for more organizers. It definitely is work to put this together. Day of logistics, as well as sometimes before event logistics, coordinating with the speakers, coordinating with the sponsors, getting funds and paying for things such as the pizza that you guys have eaten and the drinks. So always looking for more people to help out with the effort. It's definitely no easy effort, and as I've experienced whenever I go to other meetups around the world and around the country, I always appreciate those people putting in this volunteer effort. It's primarily a volunteer effort since day one back in 2013. Sponsors, always have to give credit, of course, to the people that make it happen. Coinstructive, that is one of our organizers' company, Chris Groshong, and so they sponsor the event, putting in some funds to once again help with the food and beverage. Edge, we provide the venue, so this is our office here. And then Bitrefill, they are a great company that provides the ability to use Bitcoin. Someone asked me in the audience earlier today, like, okay, well, how do I use it? What do I do with it? So obviously there's like a number go up, buy it, and goes up, and we'll talk about that more today. But for those that want to live off of it, Bitrefill is a great option. You can buy gift cards to hundreds of different retailers around the country, in addition to prepaid MasterCards that you could use to spend as well internationally. Going back, Coinstructive, they do fraud investigations. So if anyone here or anyone you know may have been frauded, scammed, Coinstructive can actually go and try to trace the funds across the blockchain and try to find where it may have hit a centralized exchange, which possibly could get the funds frozen and then returned back to the user. It is a very, very difficult process, and usually the difficulty isn't in the tracking, but it's in getting law enforcement to actually take action. But they're a great service to actually trace down funds and do fraud investigation. So once again, CoinStructive, BitRefill, and Edge, we're all the sponsors. And with that, what are we going to talk about today? So Bitcoin basics. How many people here, let's just say, do not own any Bitcoin? More of you should have raised your hand because you just all doxed yourself. Right? You all have Bitcoin. Just kidding. Anyway, so we'll talk about, I think a lot of people that own Bitcoin know that they have it because they've been told by someone else, like, number goes up, right? We're going to dive a little bit deeper into why was it a fascinating technology? Why was the world captivated by it back in, when I learned about it in 2013, but even as early as 2010, 2011? What made it fascinating versus just another thing that you could buy that goes up and down in value? So, introduction, I kind of already introduced myself, but anyway, CEO and co-founder of Edge. I used to work at NVIDIA as a senior engineer there. I've done development across all layers of the stack, and I've spoken at, I won't say a dozen, probably a few dozen different crypto conferences from as far back as 2013. So I love being able to connect with people around the world at crypto events. And one thing I've appreciated about this industry is I've got to meet some amazing, smart people. So it's been a real boon for my own personal enrichment. So what is Bitcoin, right? At its heart, we call it a digital currency. But then again, all dollars are digital, not all, but almost all dollars are digital. So that isn't really a unique thing. I think it's the combination of these bullet points. It is a digital store of value, right? And it's digitally native. And I think that's the key thing, is in the sense that, unlike gold, which is a store of value, and you can buy gold ETFs, gold is not native digital, right? It's physical, and then we made a digital version of it that can be traded, whereas Bitcoin is digitally native. But uniquely, I say it's a digital currency, but if you think about it, most currencies don't have a way to pay with that currency built into it. So gold, the built-in way you pay with gold is your hands transfer it to someone else's hands, right? The air between us is the payment method. That is the native payment method for pretty much all currencies since the beginning of time. And you had to then build a layer on top of that currency. So the dollar was paper originally, and if you think about it, the dollar was a payment method for gold. Gold was the currency, and we pegged the dollars to a unit of gold, and it was a more convenient payment method because it was lighter for us to transact. Bitcoin has its own payment network built into it. It doesn't need another one. Now, granted, other ones were built on top of it, but it inherently doesn't need one because it has its own. As well, it requires no banks. It doesn't require any governments to issue it. And the collective kind of set of these bullet points all together are what made it unique when it was launched. Because we might have had a digital currency, but we didn't have one that was also built in with a payment network, and we didn't have one that also didn't require any custodians, banks, or one that wasn't issued by a central party such as a government. So the collective nature of all of these is what made Bitcoin unique. So to kind of understand how Bitcoin operates, it's good to understand how the legacy banking system operates. So with a bank, you have a ledger of transactions, right? They have a database, and it shows a date that a transaction occurred, maybe a memo, how much occurred. In this little row, in these rows, it doesn't show who it goes to. So just pretend there's another row, where did the money go? And then what your running balance is. And the bank holds this for every person that owns an account with that bank. But they're the ones that hold it, right? They hold the actual value, the assets, the dollars. Back in the old days, it was the gold. But they were the ones that determined who held what money. And every time you made a transaction, it was their ledger, right? So you effectively trusted them to determine what your balance was, and also who you can transact with. If they decided to not allow someone to be a customer, then you couldn't transact with them. With Bitcoin, we took this ledger of transactions and we distributed it across thousands of computers. So now that ledger of the transactions and the balances, the source and the destination, became a database still, but across thousands of computers that now have a consensus network between them to agree on these transactions. You can imagine the first question you have is like, gosh, well, what if one computer just writes in a number into their balance, but another computer doesn't? How do we trust that computer? We'll go into that later. But know at least from this point that all the computers come to an agreement and they're financially motivated to come to the same agreement as to what those transactions are. So how do we actually send and receive Bitcoin? Right? How are they stored? How are they transmitted? So here's a little test of what generation are you? Who here has ever written a check? Oh, we're all geezers. Okay, cool. Well, if you think of the information on a check, right, there's a date. You can see that in the upper right. There's a person that's going to get paid. In the case of a check, it's a name. But really, at the end of the day, that name is going to translate into a bank account number. There's an amount, right? And here in a check, you write it 2 times. And then there's a signature, right? And that signature, in the case of a check, was meant to be a way that proved the person that owns the account is the one that is authorizing this transaction. And as we know, it's trivial to forge. It's insanely easy to forge. But in the world of Bitcoin, we mirror this analog paper check, but with cryptography. But almost all the same fields exist in a Bitcoin transaction. You have an amount that you want to send. You have a source account, which in here is the account number. Right? That's the source account. Maybe you consider the routing number plus the account number is the source account. You have an amount that you want to send. You have the date that you send it. And then the destination. But in Bitcoin, it's not a name. It's another account number. But the most important thing is you have a signature. Right? And that signature isn't this analog thing that you write with your hand. It's a digital cryptographic signature. And for those that are non-technical, might be difficult to understand, but know that the world of cryptography and digital signatures allows you to have an equivalent of your wrist that can sign a transaction. And that is what's called a private key. It's this long number at the very, very bottom. It is nothing more than a gigantic number. It is such a big number that nobody can guess it. It is statistically impossible to guess this gigantic number. It's so large, there's no verbal description of how big it is. But cryptographically and mathematically, we can derive a thing called a public key from that. So the private key, kind of like your wrist, is what you keep to yourself. No one should ever see that. It's what allows you to sign the check. The derived public key kind of becomes your account number that people can deposit money into. But when you want to spend from that account, you basically create this check. It's a digital check. It's a little payload of data that has all this information, what's the account it's coming from, what's the account it's going to, and then the amount. And then you create the signature with this private key. And the important thing is that anyone that sees this transaction can verify with this signature that it was signed by the owner of the public key. And since in the Bitcoin network, when someone sends you money, it gets associated to your public key or public address. If your public address now has 1 Bitcoin because someone sent you money to it, for you to spend that, you sign with this private key. Like I said, the closest analogy is it's your wrist, right? But only you have it, and it cannot be forged. Right? Cryptographically, with the current technology that we're aware of, you can't forge that signature. So as long as you have that key, you can sign checks, these digital checks. If you don't have it, you can't, and your money's stuck. And unfortunately, there's no crying to the bank saying, really, it's me. You know, I got my hand cut off, but really, it's me. In the digital cryptography world, you need to have that private key. So what does this look and feel like when you're actually using Bitcoin? Like, how are they transmitted? This is a little depiction of an in-person experience to send and receive Bitcoin. A receiver shows a QR code. That QR code is really an encoding of their public key that I just described. We call it a public address in the cryptocurrency world. And the sender scans it. And by scanning it, they're putting that public key, public address, into a check that they're creating. Their software is now creating a little check, and the destination is that code that they scanned. And then, the sender specifies an amount, signs it, and then broadcasts it to the network. And if you remember this previous slide, That's the network. It's the network of computers all around the world that are validating transactions. And they're looking at the check and saying, okay, this check is being sent from account number 123 ABC. Does it have enough money in it? If it doesn't, they throw away the transaction. All these computers say, nope, sorry, this transaction is invalid. They throw it away. If it has enough money, they then confirm it. And that transaction replicates across the network until all of these kind of copies of the bank ledger validate it and say, yep, this is good. The money is now transferred. What would normally happen at a bank, given their big central honking computer, what now happens across the world, across many different computers. So contrast that to the current financial system. So that account number that you shared with a QR code on this slide is kind of like a bank account, but think of it as a bank account that's a deposit only. That public key is a deposit only account. Contrast that with credit cards. With credit cards, the number you see on there is a withdrawal type of account number, meaning when you see those numbers, you can take money out of my account. And it's also true for your actual bank account number. I give you my bank account number and you take money out of it. So, and this isn't true in most of the world. It's true in, ironically, the most developed countries. So the US, UK, Canada have systems whereby here's my account, take money out of it. Please only take how much I really want you to. If you take more, I'll sue you. We're basically a very litigious society because we have the funds to be able to hire lawyers. And therefore, we can, quote unquote, trust that the right amount of money gets removed. In contrast with Bitcoin and just about every cryptocurrency, it's a push payment method, meaning I have to send money to that address. There's no simply taking money out, which does eliminate almost all of the fraud. Fraud from the viewpoint of someone found my personal information, they found my account number, someone saw a check, duplicated it, pulled money out. All of those types of fraudulent transactions are by and large impossible on Bitcoin. There's other kinds of fraud, right, that are still possible if someone convinces you to send them money and lies to you as far as what they're gonna give you. Different kind of fraud, but fraud in the payment system is just about impossible in Bitcoin. So I want to go into something that I think confuses people the most, and I think is the biggest mystery, which is how is Bitcoin created, right? So to many people, it's like it just comes out of thin air. Like, why in the world would I trust money that can come out of thin air because my buddy turned on a computer, right? It's like, wow, how is this somehow a trustworthy money? Well, there's a process to actually create the Bitcoin, and it mirrors mining gold. And we call it proof of work, and now that term is now getting applied to other parts of technology. The best analogy to this is a Sudoku puzzle, and I credit this analogy to one of the greatest speakers on Bitcoin, Andreas Antonopoulos. Unfortunately, he doesn't do a lot of talks anymore. But for anyone wanting to learn more about the ideology of Bitcoin and how it works, I encourage you to look up his content from 2013, 2014. But the analogy kind of goes like this, right? If you think about a Sudoku puzzle, there's numbers that start the puzzle. So these puzzles all have numbers that just kind of come with the puzzle. And your job is to fill in the blanks such that the puzzle is solved. And for those who's not familiar with Sudoku? A couple people. So the way, and I actually have to remind myself, so the way Sudoku works is the numbers you fill in have to, from this far left puzzle, that's the simplest one. It gets harder and harder as you go to the right with more rows and columns. But the puzzle on the left, you have to fill in such that every row contains one of each number, and every column contains one of each number. So you can imagine the fewer numbers you have, the harder it is to solve, and the fewer numbers relative to the size of the puzzle, it becomes harder to solve. And generally speaking, it's hard to solve, but it's actually really quick to verify. Right? You can actually give it to someone else and you say, I solved it. The person can quickly look and see that all of the numbers are unique in each column in a row. Right? So hard to solve and quick to verify is one of the traits of what's necessary for proof of work. And so getting back to how are Bitcoin created, it's really like a gigantic game. Like Monopoly, where you roll dice, first person to cross 200 effectively mines 200 fake dollars. In Bitcoin, the first person to solve the Sudoku puzzle earns Bitcoin. almost as simple as that. Now, it's not actually Sudoku that you're solving, but it's something similar to it. And the way the network operates, much like Monopoly, is that there's a set of rules. You have to roll dice in Monopoly. It has to be 2 dice that are each 6-sided, and you get your 1 roll, and then you move. There's also rules in the Bitcoin network, and if you don't follow those rules, you don't get to play, or other people on this network kick you out, right? Same thing as Monopoly. You don't follow the rules, your friends won't let you play. So one of the rules is that the network wants to mirror the issuance of gold. So if you think about when gold was first discovered and used, it was really easy to find. It probably was just on the floor. People walked around the earth and were like, oh, that looks shiny and cool, and pick it up. All right, hey, let's trade it. It's hard enough to find, let's trade it for something else. But as people started picking up and hoarding the gold and wanting it for themselves, it got harder to find. And so people then would need to use maybe a spoon to dig up the earth and go, oh, there's some gold like maybe an inch under the ground. Right? So the work got a little harder. And then after all of the gold was found that was only an inch under the ground, you now had to go deeper, maybe a foot or 2, and you needed a shovel. And then it got harder and harder to the point where now you need massive machines that are earth movers to dig tens of feet under the ground to find gold, and sensors to find where on the earth to even look. So as more gold gets found, the harder it gets. And Bitcoin really wanted to mirror that. So what it wanted to do was at first issue a certain amount of Bitcoin in a certain amount of time. And when Bitcoin was first started in 2009, that was 50 Bitcoin every 10 minutes. The thing is, you don't know how fast people are going to solve the puzzle, right? You might solve it 5 minutes, you might solve it in 9 minutes, you might solve it in an hour. But as people solve this puzzle, they earn Bitcoin. And in 2009, that was 50 Bitcoin. As more people entered, as you can imagine, if more people are trying to solve the puzzle, there's higher odds that someone solves it faster. Right? And people also come in with faster computers to solve the puzzle. And so the Bitcoin network says, oh, look, someone solved it in 5 minutes. Let's make the problem harder. And that's the analogy of Sudoku, right? They actually make a bigger Sudoku puzzle, making the problem harder to solve, making it take longer, but try to level off at about 10 minutes. Right? So difficulty goes up. You're still solving and getting 50 Bitcoin, but roughly every 4 years, we call it the halving, the network says, we're going to cut the reward in half, meaning you actually pay, or you actually receive half the amount of Bitcoin. So 2013 got cut to 25, 2017 cut in half again, all right, and so forth and so forth. I think we're at 6 or 3 now. 3.25, there we go. So we're at 3 and change Bitcoin every 10 minutes. All right. Not unlike, if you look at the curve, I wish I had a graph of this, but the curve of gold discovery and issuance, or at least what we believed is. Unfortunately, unlike Bitcoin, gold is not transparent as far as how much exists in the world and how much is being mined. But from what we believe, it has a similar trajectory, kind of an asymptotic curve of a lot at first and slowly teetering off. Same with Bitcoin. So this is probably the next part. It's going to be the most technical part of this discussion, and I'll do my best to kind of give people an understanding that are not technical of what's happening in mining. Like, what is this actual Sudoku puzzle? What it's really solving. So actual proof of work. So I've got a few different colored boxes here. So rewind yourself to that Sudoku puzzle. There's numbers that start the puzzle, and there's numbers that you add to the puzzle. And then a solution, right? Did it solve the problem? With proof of work, you also have given numbers. That's the green box, right? As a miner, you're given some numbers. And then you have to also generate a number, which is the orange box. And this is a guess. Unlike Sudoku, miners don't try to solve a puzzle. They literally just throw numbers at it. They're literally just throwing, it's like Sudoku, but you're not even thinking. You're just blindly throwing numbers and seeing if it works. That's literally how they're doing it, just blindly throwing it. But instead of the correct answer being all the rows match up, instead it passes through a cryptographic function called a SHA-256, or a hash function. And you can think of a hash function as nothing more than something that takes a number, a gigantic number, or a string of numbers, and it jumbles it up and spits out something on the other side. But you can't go in reverse. It's almost like a language you can translate in one direction, but you can't go another way. It jumbles up the numbers and spits out another number. So this blue box in the bottom right is the number it spit out. And you putting these numbers together and spinning it out another end is what's called the hash. And you do keep doing this over and over again, just like that Sudoku puzzle. Just throw numbers at it until the problem is solved. And you do it until the number that comes out fits a certain criteria. Usually it's lower than some number, like the difficulty. And once you find that, you can give your orange box out to the network. That orange box is the numbers you wrote in the Sudoku puzzle. You give it out to the network. And you say, there, network, here's my solution to the puzzle, because the network can then do the exact same operation and see that the number that came out, the bottom right blue box, that number fits the criteria, that it solved the puzzle. So you might be asking, well, what does this do from the viewpoint of why does the network do it? Is it just to issue Bitcoin? One of the most elegant parts about Bitcoin is that mining does two things. It issues Bitcoin, but it also secures the network. It validates transactions. And this is the part that's unique that doesn't have a good analogy to gold. So those given numbers, the ones that start the Sudoku puzzle, are actually all the transactions that people want to send. They're the data payload of all the checks that people wrote, all jumbled up. And the interesting thing is, in Sudoku, you're kind of given the numbers. In Bitcoin, you get to choose the transactions. You say, I like that one, I don't like that one, I like that one, I don't like that one. Why would you choose one transaction over another and to jumble up into your given numbers? You choose the ones that are spending money they have. So if you choose this check that someone wrote, and as a miner you go, oh, that's spending from account 123. Account 123 has no money in it. You don't want to put that into your given numbers, into the start of your puzzle. Because guess why? Even if you solve the puzzle and you broadcast your solution, other people on the network will look at it and go, oh, look, he chose a transaction that's invalid, that spent money it didn't have. I'm going to throw out his solution. You didn't follow the rules. That's one of the rules in a financial network, right? You can't spend money you don't have. And just like in that game of Monopoly, if you go and roll a pair of dice that says 6 and you move 7 spots, you get kicked out of the game. Even if you cross go and you try to collect 200, they're going to go, sorry, you don't get 200. And so this kind of is like a big board game that gets played all around the world. And that effort that you took into solving that Sudoku puzzle, right? That's what we call that proof of work. Whether it be Sudoku and you're just like, your mind is putting in that effort. In Bitcoin, you're putting potentially millions of dollars into computers that are going and cranking through to solve that puzzle. All that effort is wasted if you put in a transaction that's invalid, because the rest of the network will throw it away. That is what's making Bitcoin's transaction secure. That's the really key, unique piece. Whereas before, sure, there wasn't any of the mining needed, but you just trusted a bank, right? There's pros and cons. Trusted one single entity, and that entity get to decide unilaterally, is this a valid transaction or not? Here, now thousands of computers come to agreement, and this is how they come to the agreement. It's because there's actually work involved, and you prove that you put work into it because it's hard to solve the problem. One little nugget that many people new to Bitcoin don't realize is that Bitcoin's not just digital cryptocurrency, digital money, it's actually a little programmable. So that public key that I talked about, right? There's the private key and there's the public key. That public key, which is encoded into an address that you can give people to send money into it, you can actually put a little program into it. And that program determines what do you need to do to spend the money out of it. So if you've ever had a shared bank account where, maybe husband and wife have the shared bank account, you create this contract with the bank that says, the only way money leaves this account is if both my wife and I sign. That's a little contract. That's a little rule inside of your address, which is your bank address. You can add another rule that says, well, say my wife dies. Then it requires my signature and this lawyer in order to remove money. Well, guess what? Bitcoin can do that. We call that multisig or multi-signature, where you can create this address that can receive money, just like a bank account, but it can have a little program in it that says, I'm not going to accept just one signature on this check. I'm going to need 2 signatures, or 2 out of 3 signatures, or 10 out of 15 signatures, or 3 out of 7 signatures, and it has to be after a certain point in time, meaning like 10 years from now. And you can build things like inheritance into a script, a Bitcoin script. So this is, in Bitcoin, it's a very, very simple programming language. Know that one of the biggest reasons we now see a plethora of other currencies like Ethereum is that programming language became fully complex, meaning you can do loops and jumps and create variables and if this, then that. Whereas in Bitcoin, it's kind of a few lines and it can only say yes or no. At the end of the day, the script says, yes, you can send it, or no, you can't. With things like Ethereum, you can now say, based on these inputs, here's who to send money to, here's what address to send money to, here's how much to send money, or when to send money. It's far more powerful than what at least original Bitcoin has, although Bitcoin has evolved and incorporated more programmability since. But just know that there's this level of programmability that has actually been in Bitcoin for a decade, and one of the reasons why people were very fascinated about this technology. So for those that are like, well, I'm new to this, why should I care? Like, what's even important about this? These are 3 of probably the primary bullet points within the Bitcoin ecosystem that people talk about. There's probably a few others. But sound money, transactional freedom, and privacy are the 3 big things that people talk about, at least back when it was first created. Sound money, I think everyone knows, we're in hugely inflationary global economy. And the dollar is the best non-inflating currency. It only gets worse than this. And so this is the price of the dollar since the beginning of 1900. And it's gone down, I think, 20 to 1. And this only ends at 2020. This doesn't even include post-COVID inflation. Right, you can see what has happened to the value of the dollar. In contrast, the one thing I didn't cover is the supply of Bitcoin. I didn't cover that early on. And much like gold, it wanted to mirror that rarity. Like, sound money is rare money. And so the total number of coins that will exist on the network, barring a huge disruption to the consensus mechanism, is 21 million. It's wildly dividable. You can get up to 9 decimal points of 21 million, or 8 decimal points, I forget. But 21 million coins by what we know as 1 Bitcoin is all you'll ever have. In contrast to the, I think, 60 trillion in M1 dollars that exist today, and the trillions that are being printed annually. So from a viewpoint of sound money, that's one of its biggest arguments. Transactional freedom, because it's a network of thousands of computers that verify a transaction, and not a single bank or a single payment processor, a Visa, MasterCard, PayPal, that means anyone that can access the network can send money, and anyone that can access the network can receive money. And since the network is thousands of computers, it's pretty much anyone that can access the internet. And this shot, for many of you that may not recall, are a lot of the Canadian truckers that were protesting during the COVID lockdowns. And many of them, by just virtue of facial scan and identity detection, had their bank accounts frozen. So they were not able to transact, they were not able to pay bills, pay mortgage and whatnot. And that's virtually impossible with Bitcoin. So, and that extends not just to transactional freedom for someone, that is protesting and maybe doing things that a government doesn't like. That could simply be transactional freedom to a region of the world that doesn't have access to that same payment method. A farmer in Sub-Saharan Africa that just doesn't have access to anything that would allow them to receive money from someone in the US. Now they can receive Bitcoin and just about every other cryptocurrency. And then privacy. Granted, Bitcoin is not super private, right? One of the challenges is, I mentioned that check that you write. Notice the one thing you don't have to write on the check is your name. So you don't have to write your name or address or email or phone number. You just write a source account and a destination account. However, that check and all the checks that are ever written to send money on Bitcoin are fully public. Right? That's called the open, transparent blockchain, and that's true of most cryptocurrencies. So while there might not be a name associated to it, realize that if you send me money, that check shows where the money came from. And that public key where the money came from, now I can look at and see all the money that it's ever received through all the transactions that have ever been sent to that address. So while there's no name, if I can associate an address with a name because you transacted with me, then I can associate all the money that ever hit that one address. Now the nice thing is opening an address is basically free. It doesn't cost anything, at least with Bitcoin and Ethereum. So you can have hundreds, thousands of addresses. Unlike bank accounts where you sit in a teller for 2 hours to open a bank account, here you can have hundreds or thousands of addresses. However, it still isn't that private from the viewpoint of I can see what money you have in that address. And better but worse in some ways than the traditional system. But at least prevents us from having to provide personal info with every transaction. It's a little bit of a rabbit hole, but this is where privacy coins come in. And I won't go into detail about privacy coins, but I'm very excited about them. We support them heavily here at Edge. And I think that they are a future for transactional currencies. These icons are for Zcash, Monero, and Pirate Chain. And the fundamental differences with these coins is, by and large, if you share an address, you have no idea of any of the transactions that go to it. And I can send money to it, and you can't see where the money came from. And I can't see, I can send money to your address, but I cannot see anything else that happened to that address. And that transaction on the blockchain doesn't even show an amount. So you don't see how much was sent between any address. So there's no source, there's no destination, and there's no amounts. But using fairly complicated cryptography that's over my head, we're able to prove that people can only send what they have, and the miners can verify that. So know that this is definitely some advanced, much more complex cryptography and math that is way beyond the scope of this presentation, but very, very important for having a true free payment network and currency, and hence why my excitement in these projects. So I want to touch on one little thing that I didn't really cover, which is self-custody. I'll just one slide on it. For those of you that have been in Bitcoin long enough, you've heard the term not your keys, not your coins, or not your keys, not your cheese. And so self-custody, if you think about it, is what Bitcoin was built for. In order for you to gain all of the benefits that I just mentioned, privacy, transactional freedom, sound money, all of those are only gained if you hold your own keys. And when I say keys, I meant that private key, that wrist that allows you to sign the check. Without that, you're in a custodial solution. You're in a custodial exchange or a service, a custodial wallet, where they own the keys. They own that wrist. And all you are doing is you're just asking them, hello, could you please send money over to my friend Daniel? Here's his address. Or you're saying, hey, can you give me an address, please, that I can then receive funds to? But they're the ones holding it. These are basically cryptocurrency banks. They might not be licensed as a bank, but they're effectively banks. And know that you've given up just about all the privacy benefits you might get from any crypto, including a privacy-based crypto. You'd be giving that up completely. You would definitively be giving up transactional freedom. No question about it. Some people actually tried to send Bitcoin to the Canadian truckers, and they tried to receive into a custodial account, and the Bitcoin was frozen. So just because it's Bitcoin doesn't mean you get these benefits. You have to be using Bitcoin in the peer-to-peer mechanism, where it's you as the sender recipient to someone else as the sender recipient. And for those that are new, and I know there were a handful of people that are like, I'm really new, I'm not sure how to use this, not to throw any projects or companies under the bus, but some of the most popular names that are custodial solutions, Coinbase, Kraken, Crypto.com, are ones that primarily build services that hold your money, which means they hold your keys. They do provide, all of them also require full personal information, who you are, what's your address, phone number, likely social security number, And then all of that personal information gets associated with every transaction you do, every send, every receive, buy and sell. I think that's it. Although, yeah, one little shill slide. So at Edge, what do? We offer a self-custody exchange platform. Lets you buy, sell, trade, and also earn yield, being able to take your cryptocurrency and actually earn money on it, all where you fully control your funds. And we simplify the key management, whole other topic, but it is challenging to secure a private key, right? For a lot of people, they've never had to secure data that is money. Like data might be my photos, and data might be a Word doc, but to secure data that actually has true hard money, where if you lose it, your money's gone, is a hard challenge. And that's one of the things that we try to solve and build it where it feels like a very familiar account creation system that you'd be accustomed to with 2FA and password recovery, but you still have control. We don't have control of your funds. We don't actually even know how much money people hold in our app. And that's it. Just definitely give it a try. We're also open source. I think the next slide shows for anyone that's a developer. Are any developers out there? Any chance? One developer, Ed? So github.com/edgeapp is a way to kind of tinker with the source code, build it yourself, make changes if you'd like, contribute to it. And then there's all my contact information. So I think that's, last slide. So happy to open up to any questions. Yeah,
Wait for the mic, Dan.
You'll have to excuse, he's new here.
Well, I'm curious, if I was a new user, would I be able to get any bonus by downloading the app today?
If anybody would like to try Edge and is your first time using Edge, I'll have to trust you because we don't do personal information. You can create 5 accounts if you'd like. So we're just doing it by Scout's honor. We'll send you, I think I've got cards for $8 in crypto today. Happy to get you started. And one of the things I think that's most interesting about that is not so much that, hey, this is $8 can become 800, but it lets you experience actually sending and receiving it with people. Try to find someone that lives as far away from you as you know, in the most remote part of the world, that at least has access to the internet and a mobile device. Have them install Edge, send them money, and realize that you sent them 50 cents, $1, and they did it with no personal information. And it arrived in seconds, confirmed in a couple minutes. So realize that that just is not possible with the current financial system. And that's what a small amount of crypto can do. And then if you find yourself, you're fascinated, oh my God, this is revolutionary, then go buy some, hold it, convince someone to pay you in it. Then it becomes a real economy.
Great presentation, Paul. So Tyler Collins here. I'm running for Carlsbad City Council. So my question is about, thank you. So the question today is about, what do you think is the intersection of city government and crypto? Easy question, right?
No, actually, it's a tough question.
That was a joke.
Crypto, yeah. The question was a joke?
No, it is a hard question, which is why I want to ask
you.
Also, I'm a software engineer by trade, so I'm very interested in this, and I'd love to hear what you have to say.
Got it. So. Crypto really throws a wrench in most governments. I know there's been a few jurisdictions around the US where they would say, oh, we take Bitcoin for paying your parking ticket and getting licenses and whatnot. Sure, I guess that's interesting. But for most, especially here in the US, they realize that the more that they drive adoption for crypto and Bitcoin, I'm sure they realize the more that they are lowering the utility and value of the dollar, right? And at the end of the day, that was the goal of Bitcoin, right? I mean, I wear my shirt with pride. Like I'm in the anti-fiat club, right? So fundamentally, I do believe crypto is the better money in just about every way, shape, and form. And in the ways that it isn't, only software development is needed to improve it. And so, yeah, it's a rock and a hard place. They know they need to adapt, but they know that adapting effectively destroys one of their biggest competitive tools, which is money. Now, granted, governments existed for a while where they didn't have control over the money. And for many of us, we thought it was a more honest government. So if we can return to that, then great. But I would love to hear that they just simply allow people to use it, accept it, or even pay taxes in it, which I think most Bitcoiners will say, I'll never pay my taxes in Bitcoin. That's what I hold. Yeah, it's a struggle. I wouldn't want to be on that side. But for those that are going and applying to work in the government, heck, drive adoption if you're not the one that's trying to print money.
Thank you so
Yeah.
much.
Right.
Thank you for the presentation. So it sounds like if I download an excellent wallet app like Edge, I can protect my digital assets, send them around as needed. Is there, can I incorporate hardware wallets? It's not something you really touched on. A little additional security so that my 3-year-old doesn't unlock my phone and send all of my assets away or to a burn address.
Got it. So I gave an entire presentation years ago on just the different kinds of wallets. What was asked was about, like, can I incorporate hardware wallets? And I know a lot of you are experienced, but I'm going to assume, right, since this is the basics, that many of you aren't. Without going into the details of what is a hardware wallet, what's cold and what's hot, just to answer the question, currently we don't. There are different things you can do to the account to add additional security to it. Two-factor protection, you can also disable things like PIN-based login or biometric login, so therefore getting into your phone doesn't get into the app. So there's other layers you can add to it. Hardware wallet specifically not. We are looking more at going into multi-sig style security, but haven't decided what's the user experience that would do well for the average user. Multi-sig is great from an organizational point of view. If you remember the slide where I showed the multiple keys that can sign, this one right here, right? Multiple inputs, which could be multiple signatures. It's great for organizations, like this meetup group, right? Where you can have several people that have keys, several have to sign before money goes out. But for an individual, it's much harder to determine how multi-sig fits. So answer your question, it is a software wallet at this point, but with a lot of additional security layers baked into it.
Hello?
There you go.
Hello? So Paul, the example you gave where we send money to somebody that's far, Bangladesh, somewhere really far away, there's gas fees, right? And how are those calculated?
Wow, it's an entire blog article I remember writing years ago. Gas fees, you're right. So one thing I didn't cover in mentioning how as a miner, you get to choose the start of your Sudoku puzzle by picking these transactions. And you obviously want to pick transactions that are valid. They're not spending money they don't have. They follow the rules. But also a big motivating factor is the transaction that pays the most fees. One of the things that's not in the check, in a way, is kind of like the little tip. Please confirm this transaction. Here's a little bit of money to do so. And the one that pays the most is kind of the one you want to pick, right? As long as it's valid. Now, how fees are calculated, oof, how much time we got?
As long as I don't care if it gets
Yeah.
3 weeks from now, I don't have to pay as much.
It depends. So the way the Bitcoin network works is unlike the checks in the bank, where your account is just a flat dollar amount. Once you've cashed that check, you just have a certain dollar amount in your bank account. You can think of Bitcoin more like a cash register. And every time you receive Bitcoin, it's that check. It's a cash register full of checks of money you've received. And so unlike having a register of 20s, 10s, 5s, and 1s and coins, you'd only have a register of, okay, 0.021 Bitcoin, 0.00123, 123.5 Bitcoin. You just have all these checks of the amounts you've ever received. And so if you think about a cash register, I remember when I was a kid, I ever have those days where the kid walks up, back when you had to pay cash for things, walks up to the lunch lady and pays in pennies, right? Where it takes the lunch lady forever to count the pennies. So in the same sense, if you go to spend the Bitcoin, would you want to spend your Bitcoin that's just simply in one check or in 1,000 checks? Like, what's easier, right? Obviously, it's like one check. So how are fees calculated? They're calculated on a few different metrics. When you create that transaction, it doesn't actually look just like a check. It looks like a check that has, go back that check here. It is a check that instead of saying pay to the order of Satoshi 1 million, it can say pay to the order of Satoshi 1 million, pay to the order of Daniel 1,000, pay to the order of Joe 2 million, pay to the order of anyone. You can literally pay multiple people, multiple addresses all at once. And instead of having one account number, it can have 100 where the money's coming from, right? So all those checks that went in the cash register, when you spend them, you can spend them as one check that references all these other checks. It's kind of a weird analogy, it doesn't exactly work. But I can say, oh, this check, this check, this check, put them all into one transaction, create a new check. But all of those checks make a bigger transaction that the network has to look at, has to validate, and it costs the network more energy and time, and it's going to cost you more in fees.
So what you're left over with is the UTXO?
So that's what's called a UTXO in the network. We call it unspent transaction output, which is the money you've received. All those checks sitting in your cash register are UTXOs. So you ever heard that buzzword? That's what we're talking about. They're just these checks of what you've received. But you pick which ones you want to use to spend. The more checks you pick, the more the transaction is going to cost. And then also you can send to multiple outputs. You can send to multiple other addresses. The more addresses you send to, the more it's going to cost. And the Bitcoin network charges you not by the amount you're sending, but the size of data that you're sending. So obviously if you send from more checks and you send to more destination addresses, that's a bigger transaction. And so we call that at the metric as far as what is my transaction cost, we call it Satoshis per byte is what the network is currently charging. So Satoshis, think of it as just Bitcoins per byte, per kilobyte. So how many Bitcoins am I going to pay for this transaction per kilobyte that I'm using? And whoever pays the most Bitcoins per kilobyte are effectively going to get into the network if you don't pay enough Bitcoins per kilobyte. So it's not just purely how many Bitcoin you pay in fees, and it's usually not a whole Bitcoin, right? It's a fraction of, but it's not how many Bitcoin you pay, it's how much you pay for how much space you use. Just like a bus, right? The blocks in Bitcoin are like a bus. There's only so many seats. So it's not how much you pay to get in the bus, it's how many seats you take. And if you're a big dude, you might take up more than one seat. You'll have to pay for 2 seats. And a transaction might have to pay for many bytes. So hope that kind of answers the question. It is very complex and has no great analogy in the real world for how we pay with credit cards and checks. And people do get surprised, like, oh, I only sent $5 and it cost me $2 to send 5. But just yesterday I spent $1,000 and it cost me 50 cents. That's totally possible. Because maybe the check was bigger, right, when you sent $5. Because someone sent you a bunch of 50-cent checks.
I was going to say the U.S. just sent a few billion to a Coinbase account, and it cost them about $3.
Yeah. Yeah. Probably came from just a few UTXOs, a few checks. So in that sense, by the way, Coinbase in 2017 had about $10 million they could not spend because they received these small checks. And the cost to spend the check in Bitcoin per byte was larger than the value of the check. So we call that dust. It was stuck there. It's like literally if someone sent you a check for 2 cents, but the bank won't cash it for less than 5, you're effectively stuck. So that was dead money until the fee cost dropped. Once the fee cost dropped, they went and consolidated the UTXOs, which are the checks. You can make a big transaction that consolidates it into one check that you then receive back into your cash register.
So yeah, I had just a small side statement before my question. When you were talking to this gentleman, you said something about the government controlling the money. The government doesn't actually control the money. We both know that. But that's a whole nother topic. But either way, my question, I actually know the answer to it, but it's something that everyone asks me, particularly around halving. And so I figured I'd bring it up in case other people had questions that were either watching online or here.
Awesome.
So obviously, the more people that are mining, the more difficult it becomes, the Sudoku puzzle per se. And that means the more expensive the equipment becomes.
Mm-hmm.
And as time goes on, obviously the reward gets lower. So in the instance that the reward gets so low that for some people it becomes too expensive for them to mine more, does everything just shut down or does the difficulty go down?
So the hope is the value per unit that you mine goes up. So when Bitcoin was first 50 Bitcoin per 10 minutes, Bitcoin was worth nothing. At some point, it was 50 Bitcoin per 10 minutes, but it was worth cents. So you were getting 50 cents every 10 minutes. And then that went up and up and up. And by the time of the first halving, Bitcoin was worth $30-ish or so, upwards of 200. It spiked up real quick. So the hope is every 4 years, at minimum, Bitcoin needs to at least double in value for us to be mining a rough equivalent amount of dollars worth of energy that's going into. We call it this, there's a term called the security budget, which is how much are these miners being rewarded in dollar value for the work that they're doing. If they're being rewarded a really small amount of dollar value, then they're kind of not incentivized enough to not cheat. The more they're rewarded, which means the more that they can lose if they confirm an invalid transaction, allow someone to spend money they don't have, the more they're rewarded, the more you don't want to cheat. So in order to retain what we currently have as far as security budget, yeah, Bitcoin has to double in value every 4 years, because every 4 years, the amount of Bitcoin you receive goes down, or they have to receive more transaction fees.
But if it doesn't, does the Sudoku puzzle get easier as less miners have covered?
Yes, it would actually get easier.
That's
Correct.
what I was getting to, because that's what a lot of people ask me.
Yeah.
Hi, Paul. Question that I have, because I've
A little closer to the mic.
Gotcha.
There you go.
Does Edge have any plans on Lightning daemon integration into the app, just for higher throughput and just lower cost per transactions?
Common question, do we have any plans for Lightning? For those that don't understand what Lightning is, because it's the basics, Lightning is a protocol layer on top of Bitcoin that tries to facilitate faster, cheaper transactions, because Bitcoin transactions can be very expensive. We have dabbled in and tried to use Lightning through some SDK partners and have deemed it very difficult to use at scale. And one of the most established companies in Lightning that we were trying to partner with and utilize their SDK, which they use in their own wallet, has claimed it would be very difficult to guarantee a transaction over $2,500 would confirm. Now, not confirm, would actually succeed and not fail. And so given that our application, from the definition of what we're trying to facilitate, is buy, sell, and trade, people trade above $2,500 all the time. And the effort to get into Lightning is already high enough, like being able to fund a Lightning account and keep it funded is high enough that we felt that the direction to go to are in other newer Bitcoin L2s. So another buzzword, L2 means layer 2, which are layers on top of the main Bitcoin network that allow settlement on the Bitcoin network, but transactions off them that are faster, cheaper, and have potentially more programmability, like Ethereum. Lightning doesn't have that additional layer of programmability, so it's a tremendous amount of extra work and far lowered user experience without a lot of that extra functionality that you get from the programmability of Ethereum. So our direction is more poised towards the Ethereum compatible Bitcoin layer 2s.
Is that Zcash and others, right?
Not so much Zcash, Spider Chain, Alpin Labs, of which one of the founders is actually here in San Diego. They're working on a Bitcoin L2 using ZK rollups. A few others I can't remember off the top of my head, but those are the two ones that most quickly come to mind.
Would Fedimint fit in there?
Not really. Fedimint is, to my best understanding, a custodial solution. So it asks about Fedimint, and that I barely consider an L2, but I have not studied it well enough. But our developers in our team, sharper than me, smarter than me, have. And the key word that they keep coming up with is it's a custodial solution, which means someone else is holding the money. And as I mentioned, that to me is a dead product. Once someone else is holding the money, I have no interest in it. Other people might, but once again, the benefits of Bitcoin, right? Like, why are we in this space? What can we get from it? All of that is by and large gone if someone else holds your money. Right. Sure.
This is beyond the intro, but recently inscriptions. There's now Runes protocol on top of where do you see that kind of additions to the native Bitcoin network? Do you see them growing legs and actually finding purpose on it, or is it just a distraction?
Hard to predict, although most of that technology, runes are tokens on Bitcoin. I didn't even cover tokens in this presentation. Tokens are another asset someone can issue that moves on a network, on a different network, such as Bitcoin or on Ethereum. And so my take on runes, ordinals, the NFTs on main layer 1 Bitcoin is that we've had those years ago and they didn't take off. I think they're taking off now because Bitcoin was striving for anything new, right? It was just like, when you're in hell, you'll take a drop of water, right? And it was striving for anything new. In contrast, as soon as those things were on Ethereum, they skyrocketed. And why is that? Is because on Ethereum, they're fully programmable. I can take an NFT and trade it on a smart contract and not have anyone in the middle, right? Send and receive it between people. Tokens on Ethereum can be used as an asset that I can vote with. Right? You can create governance with a token. You can create an algorithmic stablecoin, something that's stable not because some company is backing it with dollars or gold, but stable due to over collateralization with another asset. Like you can do that on a very programmable chain like Ethereum. And now the concept of tokens that existed on Bitcoin but didn't have all of its capabilities skyrocketed on Ethereum because you could do things in a very programmable, censorship-resistant, self-custody manner. That's coming to Bitcoin, but it's not coming via ordinals, inscriptions, runes. It's coming via the L2s. So in that matter, I think those have the biggest potential for true utility, not like excitement, but actual use. And I could be wrong because humanity is irrational. It's one thing I've learned. A lot of things I did not think would be popular are, even though they're not rational. So I could be wrong, but I tend to be maybe over-rational. But yeah. Try to take, what time is it here? All right, so I'll pass it. Take one more.
If I have a quantum computer, can I steal all your Bitcoin?
So if you have a quantum computer, one of the things that you can, the main thing you can do with a quantum computer, I'm sure you already know this, right, is you can reverse some elliptic curve cryptography. So that public and private key that I showed you, right there. The private key on the bottom, public key on the top. You show everyone your public key, you sign with your private key. Obviously, if you can go from the public key to the private key, that's bad, right? Because now it's when we take your money. So the current algorithm used in Bitcoin to do this cryptography is prone to an attack by quantum computers, no question about it. There's one thing that we do though in Bitcoin is that this address is not a public key, it's called a public address. And it uses cryptography that's not prone to quantum computing, which is a hash. So we take the public key and then we hash it into the public address. There are some huge caveats though that still allow a quantum computer to spend. If you ever used your address and then received more money, technically a quantum computer can steal that. But if it's never been used, then you're okay. As well, if you're a malicious miner, the moment when you go to try to send your money out of the address, a malicious miner with a quantum computer can then figure out your private key and then spend your money before your spend occurs. So overall, generally speaking, yes, a quantum computer can steal your money. Interesting question is how much money is there to steal versus the cost of the quantum computer that can do it. I did go to a presentation that had a curve of the adoption of quantum computing, and the concern as to when will it achieve power enough to break the cryptography in Bitcoin, and it's some of the estimates are anywhere from 10 to 30 years. The fortunate thing is that there's already cryptography that's quantum resistant. The question is, when does Bitcoin move to it and actually shift over to using that cryptography? Some cryptocurrencies have already been launched that are quantum resistant. But Bitcoin being old and a lot of people disagreeing on things, and it's really hard to change, does make it a challenge. It moves very slow. But it is possible, and when the thread is there, usually the Bitcoin network and the people that are running the nodes agree much faster. But you're absolutely right, the current cryptography can be broken when quantum computing gets to that level. Cool. All right, I think, we got one more. Tyler, I'll let you end it. Mr. Chairman, City Council.
No. So I think my initial question was poorly phrased. What I really meant to ask, and the reason I was saying it was a hard question, that wasn't a joke. It is a hard question.
Yeah.
The question is, how as a city council would someone advocate for the adoption of Bitcoin? And how could you pitch to the citizens of a particular place the benefits of adopting it?
So in the US, admittedly hard. I could easily pitch this in a lot of developing countries. And it was a perfect fit for one of the countries that adopted it the most, El Salvador. They didn't have their own currency, beholden to the US dollar, and needed an asset that they could kind of rally around separate from another country's money that they were beholden to. So it makes sense there. From the viewpoint of pitching it to a government to adopt it, to the citizens, the pitch is similar to this. It would be weird coming out of the mouth of a government official, right?
Well, it's weird for a libertarian to run for government, isn't it? So.
No, absolutely. Well, it depends. Libertarian, anarchist, depends on how much government you want, right? So, I don't have a great answer to that. Coming from that viewpoint of I am a person as a government official. Probably the store of value narrative might be the biggest one. From the viewpoint of every entity in government has a treasury, right? And they have to manage the treasury across multiple different assets. Chances are it's not only dollars. It's probably some level of investments, especially at the country level. At the federal level, there's some gold and other assets. And so I know that's like what Kennedy pitched, like, we're going to hold some Bitcoin. It's just part of the treasury. That's easily one of the best ways. And then from that, you could say, how do we build up the treasury? Oh, well, we just accept it. We accept it as a native payment method for whatever people need to pay for. But then it probably starts from that store of value narrative because they're already storing something, making some investments. And most large boatloads of capital are doing something with it. Because even the government knows that money's getting inflated.
You make the good point about holding gold. So they already do have some diversification of the assets they're holding, right?
That's my presumption. I know it happens at the federal level. Like city council, I have no clue. I don't know how.
I don't think we have a vault in Carlsbad, so.
There you go.
And if we did have it, I wouldn't tell you about it.
So yeah, they can diversify some of that gold into crypto.
Well, thank you very much.
No problem. Great. Thanks, everyone. So I'm here for a little bit. Happy to open up the questions on the side. And as Daniel asked, if any of you are new to Edge, happy to send you $8 and some crypto. Get started and give it a try. And do please send us any feedback. Cool. Thanks a lot. Cool.
I'm new to Edge 10 times over. Can you send me 10?
Just gonna get inflated away. And again, if you were to hold just cash, because it's melting away. So if you don't use it, you really are losing it anyway. So that would be it. Change of,